Hey everyone, welcome to the final lesson of Algebra 2. The last thing that we're going to talk about is this idea of, why is my thing doing that? Hold on. The last thing that we're going to talk about is this idea, I wanted to actually do. Okay, so, my pen's really acting up. Sorry about that. Okay, so this last topic that we're going to talk about is this idea of conditional probability. Now, I saved this one for last. I saved this topic for last because conditional probability is the only one of the probabilities where you kind of have to really use your brain and you have to come up with a formula on the spot depending on what the question asks you. And we're also going to throw in kind of everything that we've learned up to this point into these questions. So just so you know, for this week, this is the final lesson. And then I'll be putting a review up on, for Wednesday, Thursday, depending on which day you show up to do my things. There'll be a review up on Wednesday for the unit test. Remember, we're not going to have a final this year because we're basically at home doing online learning. There's not going to be a final, but we do have to have a unit test on this thing. And it's just a unit test, not a final. And we'll be doing that next week, and then we're officially done. So you can be done early next week if you so choose. If you want to get the work done, you can actually be done my class early next week and have it completely finished. Okay, but that's up to you. But you will have until the end of next week to do it. But here's our final lesson, conditional probability. And I probably don't even need to give you a definition because the definition is, it is exactly what it sounds like. These are probabilities. So this is a probability where, you guessed it, a condition where a condition is given. Okay, a probability where a condition is given. We call that a conditional probability. And the key word here, the real key word, is right here. Okay, when you see the word given in a question, that is a dead giveaway that we're talking about a conditional probability. And you're going to have to remember that because, when we put all these different probabilities together and we just start asking questions, your guys are going to have to be able to come up with, well, which type of probability is this? And this one is the more difficult one because sometimes, I can't really give you a formula to follow. You're going to have to, it changes based on what the question's asking you. So, but in a nutshell, okay, conditional probability is where we have a probability and some sort of condition is given to us that has to be met first before we can figure out the probability of it happening. So to do that, let's dive right into an example here. Let's say that I did a little survey of 100 people, and I asked them the question, "Do you like coffee or tea?" Okay, so I'm going to ask 100 people. I'm going to ask 100 people. Okay, I'm going to ask them the question, coffee or tea? 100 people, coffee or tea? And then I did that. I asked 100 people. I wrote down all my results, and then I'm going to organize my data. We could make a two-way chart, or we could make a Venn diagram. I'm going to do a Venn diagram for this one. So this box is going to represent, this box represents the 100 people that I asked. All right, let's use red. Okay, so let's say that I asked 100 people, and out of those 100 people, let's say I had 13 answer the question. 13 answered the question and said they like coffee. So these are my coffee people. They liked coffee. And let's do blue. Let's say I had 25 people who said they like tea. They like tea. And I had some people, so I'm going to draw my circles here because we are going to make a Venn diagram. Or I guess these are going to be more like ovals, not really circles. Okay, so I had some people said that they liked both coffee and tea. So let's say I had 46 people indicated that they liked both coffee and tea. That's why they overlap here in the thing. We're just making a Venn diagram. And they're going to write another number down here. I'm going to write the number 16 right here. So I want you to take a second, think about, well, who are these 16 people? What does this number mean right here? Take a second, think about that. Who are these 16 people? Well, these are the people that answered. We were asked the question, do you like coffee or tea? And they said, I don't like either. That's these 16 people here. Okay, so let's ask some questions now. Let's start with question A. So in all these questions, remember, we're going to choose a person at random from the survey. We're choosing one person at random and we're asking these probability questions. Okay, so find the probability. Find the probability. Find the probability that this person. Find the probability that this person does not like coffee. Find the probability that this person does not like coffee. So what I want you to notice right off the bat in this first question that we're asking is notice that in this question I did not use the word given. There's no given in this question. So like I said, be ready for anything in this when we're doing this conditional probability section. Be ready for any type of question from anything that we've learned from the probabilities. So this first question, notice that there's no given. The word given is not used. There's no condition being laid on us in this question. It's just looking at the thing as a whole. There's no conditions. What's the probability that they don't like coffee? Now, do you remember what we call this? Now, we'll probably put some vocabulary on the unit test. So make sure that you understand the vocabulary. Do you remember what we called this thing where there's a not condition? Do you remember what we called that? Remember what the word was? If you did, that's pretty good if you did remember. This is called a complement. Okay, so this is a complement question. Okay, find the probability that this person does not like coffee. Okay, well, in this case, we do have a formula. We know what the formula for this is. The probability of not something, so probability of not coffee, is equal to 1 minus the probability that they do like coffee. So to answer this question, obviously I'm going to need to come off over here and I need to know what the probability that they do like coffee is, so I can figure out that they don't like coffee. So this is just a straight up probability question. So desired outcomes on the top. Okay, so desired on the top, total on the bottom. So out of all these people, where are the people that like coffee? Let's find them. Where they are located. Well, these 16 here don't like coffee. These blue 25, they don't like coffee. They only like tea. These 46 people here, they like coffee and tea, but they do like coffee. So we have to count them. We have to count those 46 people. They do like coffee. And these 13 people here in red, they only like coffee, but they do like coffee, so we have to count them. So plus 13. 46 plus 13 like coffee. Out of, well, we said the survey was for 100 people. So let's figure that out. 46 plus 13 is 59 out of 100. So, or 59% of them, 59 of 100, like coffee. So now we can go back here and figure out what the chance is that someone is not coffee. So this is going to be 1 minus 59 out of 100. Which, you should be able to do that, but just in case you don't, you can convert this 1 into hundredths, and 1 is obviously 100 out of 100. Okay, minus 59 out of 100. Now you can do it real easy. 100 minus 59 gives you 41 out of 100, or we could say 41%. So there, now we've answered the question. So choosing a person at random out of these 100 people, you have a 41% chance that the person that you picked doesn't like coffee. Okay, let's do another one. Let's do another question. Okay, so this will be, we'll call this B. Whoops. B. All right, let's ask the question. Let's do this. A person who likes tea is given. Find the probability that this person also likes coffee. A person who likes tea is given. Find the probability that this person also likes coffee. Now you will notice what's different about this question is that notice that it has the word given in the question. It makes a given statement. It tells us that a person who likes tea is given. So that means out of your 100 people, we're given a person that likes tea. That's a condition. So we've just been handed a condition. So we can no longer look at at everybody in the survey. Okay, we have to exclude some people from the survey now. We are given a person who likes tea. So we can only look at the people that like tea now. Find the probability that out of these people that you're given, the ones that like tea, find the probability that they also like coffee. So this question is asking me, and this is sort of going to look like a dependent question, okay, but we're not going to be doing any multiplication though, but it does look like a dependent question. It just doesn't have the multiplication because there's not more than one pick, okay? But it sort of looks like one. This is asking me, given the find the probability that somebody likes coffee, and here's the condition, given that we're given a tea person. We're given tea. Okay, so our question is asking us, find the probability that a person likes coffee, but we're restricted to only looking at the people that like tea. So that's the condition that we're given. So we can just use our straight up formula. You know that to find any probability in particular, it's the desired number of outcomes on the top, okay, over the total number on the bottom. So that's why I said conditional's kind of tricky, because you'll see this can change. This can change based on what we're told. Okay, but let's work through this. Okay, so we're given only the people who like tea. So that's the pool out of which we're choosing. That's our total number of people as they have to like tea. Well, who likes tea in the survey? How many people like tea? Not these 13 that like coffee, and not these 16 like either, but it's the other two. It's these 46 plus 25. So there's 46 that like coffee and tea, and there's 25 that only like tea. Okay, so that's the pool out of which we have to work. 46 plus 25 is 71. Okay, that's 71. So that means that our total that we're choosing out of, the number on the bottom, okay, our total pool of people is 71. We've got to pick out of these 71. Now, out of these 71, how many like coffee? Well, we can get that information just by looking at our chart or our data. Right? You might be looking at a two-way table when you do this. Okay, but you got to come back up here, and now we are looking for the people who like coffee out of, so remember, we're restricting it just to this circle. This circle on the right that's about tea. Okay, the people that like coffee that are included in these people are only the 46. So 46 of them also like coffee. So it's a 46 out of 71, and if you really want to, you can put that in your calculator and get a percentage. 46 divided by 71 gives me about 64.8%. 64.8%. Okay, so if you're given a person who likes tea, you have a 64.8% chance that they also like coffee. Okay, so you got to watch for the givens, and you got to figure out what it's asking you, and kind of make up your. You got to make up a formula based on what it's asking you. All right, let's try. Let's try one more question. This is going to be more like a reminder question. Okay, kind of like what we've done before, but like I said, we're going to throw all the stuff because conditional probability is not a big topic in and of itself. So we're going to throw all the stuff in for it. So let's do, this is going to be C. So in this question, we're going to tell you that two people are chosen at random. Okay, so it's already a little bit different because now it's telling us that we're not just picking one person, we're picking two people at random. Find the probability. Find the probability. Find the probability that both like coffee. So I'm going to pick two people at random. What's the probability that both people I pick, that both of them like coffee? So now you have to think, what type of question is this? Well, there's no given. Okay, they don't say given. There's no given. There's no condition laid upon me. So there's no given. So for what I'm going to do is I'm going to, first of all, let's write down what is it asking me. Okay, so probability. This is asking me the probability of a coffee, and so we're going to use that little symbol. Maybe I'll do that in red just to make it really stand out. That little symbol and another coffee. Coffee and a coffee. What's the probability of coffee and a coffee? So what type of question is this we have to think about? It's not conditional. It's not a straight up just a probability question. So is this independent or dependent? Does the first person that I pick have any effect on when I go to make a second pick? Is it like rolling a dice or flipping a coin? Well, no, it's not like flipping a coin or rolling a dice. This is going to have an effect, right? So when I pick the first person, I want to get two people that both like coffee. If I pick somebody that likes coffee and I get that on the first pick, it does affect my chance on the next pick, doesn't it? Because I've just taken one of the people out of the total I can pick. So this is a dependent question. This is a dependent type question. Okay, this is a dependent type question. So in other words, what I'm going to have to do is I'm going to have to do the probability of a coffee. Then I'm going to have to multiply, because remember, dependent means multiply. So I'm then going to have to multiply it by, I want to get another coffee. Okay, but given that I already took coffee on the first pick. Okay, so let's figure this out. Let's put our odds in and figure this out. Okay, so on the first one, it's easy. What's the probability of picking someone that likes coffee? Okay, well, we know it's out of 100 people. We know that much. When I'm making my first pick, it's out of 100 people. Okay, who likes coffee? Well, the people who like coffee are these 46 plus 13. That's 59 people. 59 people like coffee. So on my first pick, I have a 59 in 100 chance of getting someone that likes coffee. Now what about on the second pick? So if I've gotten that person on the first pick, that's going to change the odds on my next pick. So if I've taken one person out of the whole survey, I no longer have 100 people to choose from. I only have 99 people to choose from now. Okay. Now, I did take someone that likes coffee out of the equation. I've already picked someone out that like coffee. So there are no longer 59 people to choose from that like coffee. There are only 58 people left now that like coffee. And this is going to give my answer when I put it together. Okay, so the bottom's easy. 100 times 99. You don't need a calculator to figure that out. That's 9,900 people. Okay, well, not people, but my odds, sorry. 100 times 99 is 9,900. Okay, now you might want to use your calculator and do 59 times 58, and we get 3422. 3422. Now I might want to actually divide that. Let's get, because if you're going to tell someone, oh, well, you have a 3,422 out of 9,900 chance, that doesn't mean a whole lot to anybody, right? Let's get a percentage. So 3422 divided by 9900, and let's round it. That's about a 34.6. 34.6. 34.6% chance. So you have roughly one in three chance of getting two people. If you choose two people, one right after the other, okay, you have about a 1/3 or 34.6% chance of getting two people that like coffee. Okay, so that's conditional probability. We can also do it with a. I'm not going to go through a full example with you, but I could have given you a two-way table as well, right? We could have done a two-way table, had different categories. This is your out of total, and the same thing. When I ask you certain questions, you might be just looking, if you're like, maybe you're given something, right? Let's say you're given, let's say we have age groups, 0 to 10. If we're given a certain age group, then obviously you're going to be looking at the total right here, the people that you're given. It's going to be out of that, and how many of them are probably one of the things on the side here. Okay, but you can do this with a two-way table as well, not just Venn diagrams. Okay, and conditional probability almost always involves either a Venn diagram or a two-way table. Okay, almost always. But you'll see there's some pretty unique questions on the practice work for you to try. Some of them are pretty tricky, so hopefully I'll hear from some of you. So since this is the last lesson, let me just give you the rundown of what's going to happen. Okay, where we're going from here. So you're probably on Monday or Tuesday going to watch this video and do this lesson. Okay, so what we did today, this will be the practice work will be due this Friday. Okay, that'll be due this Friday. On Wednesday, I am going to upload, there will be available for you a review for the unit test. Okay? And notice I said unit test and not final. There is no final in any of your courses. No teacher should be giving you any kind of a final, because you are not supposed to have a final in any course. Remember we changed the grading. Your second semester, or your second quarter, your fourth quarter is going to be a 50% total of your overall semester grade, and there's no 20% component for a final. Okay? So there is no final, but we do have to do a unit test. So I'm going to put the review up for the unit test. This is basically a test on all the stuff on probability that we've done, or what we've called Unit 9 on Canvas. Okay, so this is the unit test for Unit 9. Basically everything we've done, just go back and look at your notes. Anything that has Unit 9 and onwards, okay, is what is going to be on your unit test. It's not going to be exceptionally difficult. I am going to make it multiple choice. Okay, it is going to be a multiple choice test. I haven't decided how many questions. I don't know yet, but I am going to make the final unit test multiple choice. It's not going to be exceptionally difficult for you to answer this, unless you've completely ignored everything we've done so far. But I expect most of you will find this not exceptionally difficult if you've been doing the work. This shouldn't be terribly difficult for you. In fact, the review will probably be much more difficult than what the actual test is going to be. All right, but I'll put that review up on Wednesday, and then next week. Okay, so next week, the final week of school that we have, I will put the unit test online. I don't know if I'll do it right on Monday. I might not put it on Monday. I'm going to guess maybe Tuesday. Okay, this is just a guess at this point because I might change my mind, but I would like to leave Monday kind of a day for people to come and ask me questions about stuff if they need help before they do the unit test. But probably Tuesday next week, I will probably put the unit test online. And once you do the unit test, so you could be done next week on Tuesday, you could be done with Algebra 2. All right, so you might only have till next Tuesday, not, I mean, the week after, not next week, but the following Tuesday, you could be done with Algebra 2 and have it all done. Okay? All right, and that's kind of how we're going to end the year. And then your grades, obviously, I'll have your grades as soon as you do it. I will have your grades in the grade book at the end of that week, and you will know exactly where you stood with Algebra 2. Just so you're aware, Skyward, because they had to alter Skyward a lot, they had to go in and change all the formulas, and like they had to really mess with Skyward to get it to work, because Skyward was obviously programmed and coded in a way that had a typical school year in it. So you may see some weird stuff going on in Skyward. If you do, just relax. They know that it might be an issue. Just they'll get it all sorted out. So don't be in a panic if you see problems in Skyward. Just relax. Okay, it'll all work out in the end when they get it all figured out. Okay, it won't mess up your grades, or they will have that all sorted out for you. So don't panic. I guess the last thing I will say, since this is the last lesson I'm going to give you, is it was a fun year. I didn't like how the year ended. This was no fun on my end. Um, Basically, there's probably about 80% of you out of there's 177 of you across my 6 classes that I have with you. I'm going to say that out of that 177, I think I've only spoken to maybe 15 of you, maybe, maybe just a slight little bit, but under 20, definitely less than 20. There's at least probably 150 of you that I haven't heard a peep from. Haven't talked to you, had no communication. So this is a crummy way to end the year. You spend the year getting to know you guys, and we kind of end the year like this, where I don't even really get to say goodbye or anything. So, anyways, I hope that you enjoyed Algebra 2. I know a lot of people don't like math, but I hope I did a good job trying to make this somewhat enjoyable for you, and that it was a nice. You didn't dread coming to Mr. Bell's class. I hope that you enjoyed our time together this year. Good luck in the future. Um, I'll end with making sure that this unit, this last thing that we're doing, conditional probability, has some tricky questions. I'm going to be online every morning at 9 and 10. Just go to Canvas, click on the link, come talk to me if you have questions. I know some of this is going to be tricky for some of you, so hopefully I'll hear from some of you and you'll come and ask me some questions. Okay, other than that, I'm out. Good luck. I hope you do well in everything you do in the future. And my door is always open. Come visit me next year if you want to. Pop in and say hi if you want to. All right. Okay. So good luck finishing this out, and I'll say goodbye.